we did was to look at a given term in terms of the previous term. And does anyone remember what we call that? That kind of a formula that we developed? And there was that fancy word, Doug, a recursive formula. And if you were interested in, say, finding the 10th or the 15th or even the 117th term, say, of some series or some sequence, I think perhaps you'd have a little bit of difficulty, or it certainly would be tedious in order to do so. And what we'd like to do today is to see if we can't develop a formula which will enable us to find those terms directly. Okay? So let's see how it goes. Well, let's start out with our general sequence, a sub 1, a sub 2, a sub 3, and let's leave out some terms, comma. Let me go right to the a sub n term, shall I? And I'll put in some more dots to indicate that this sequence might continue. Let's look at the first term here, and let me simply rewrite it in a somewhat different pattern, all right? In which if I were to write a sub 1 equals, let me just say a sub 1 plus 0 times d, because I'm adding 0 to the first term. All right, now if I then were to look at a sub 2, it then is the first term plus, and we may think of this as 1 times d, is that right? In which we are adding this common difference d to the first term. And then a sub 3 is going to be that first term plus, and what may we write here? This is then going to be 2 times d, is that right? Okay, now we could have written it perhaps as a sub 2 plus 1d, is that right? A sub 2 plus another d, which in terms of this substitution would enable us to arrive at this statement right here. Oh, let's go down to another term, a sub 4 then, I think you'll agree may be written as a sub 1, and what may we say here? Plus 3 times d, is that right? Now notice in each case that here we are at the fourth term, and the factor that we are multiplying through by d here is 1 less than that. And I think if we were to put in some dots, and let me now generalize this, in which we have a sub n, then it's going to be equal to a sub 1 plus, and now what may we write here? So,
and the quantity n minus 1.
The quantity n minus 1 times d. All right? And this formula right here is one that you simply have to know. We give this a name. We call this the general term. All right, this is the general term of an arithmetic sequence. In fact, let me write that down as our heading, as the general term, all right, of an arithmetic sequence. A-R-I-T-H-M-E-T-I-C, of an arithmetic sequence. Now notice that the sequence must be arithmetic in order for us to be able to write down this general term. All right? So it's then a sub n is equal to a sub 1 plus n minus 1 times d, where d is that common difference. Okay? Let's look at a number of examples which I think will help reinforce this formula. For example, suppose we have this problem. Find the 15th term of negative 7, 2, 11, and so on, of this sequence. Now the first question that you have to ask yourself is this sequence an arithmetic sequence? And the way in which one answers that, of course, is to look at 2 minus a negative 7 is equal to what number? 9. And then 11 minus 2 is equal to 9. So sure enough, I think you will agree that we have here an arithmetic sequence. Now let's write down our formula. A sub n then is equal to. And what then is the formula that we just developed? Tom?
Negative 7.
Well, let's just write down the formula first, if we may, just to see what it looks like. A sub 1 plus
n minus 1 d.
n minus 1 times d. All right, and now in this case, it asks for find the 15th term. So we're talking about a sub 15 is then equal to, now a sub 1 in our sequence is negative 7 plus, and now here we have n minus 1 where n is 15, so this then is what? 14 times d, which is 9. Okay, let's just then do our arithmetic. We have negative 7 plus, and now 9 times 14 is what number? Bill?
126.
126, and then 126 minus 7 is equal to 119, and so I think we will agree that the 15th term, let's write that down, the 15th term is 119, okay? And notice here we don't have to find the 14th term and the 13th term and so on all the way back to the first term. but by this formula, we can find it directly. Okay? Let's look at another example in which I'll turn the problem around a little bit, in which it says which term of the same sequence, negative 7, comma 2, comma 11, and so on, is 65. All right, so let me write down our formula again. A sub n is equal to a sub 1 plus n minus 1 times d. And now we know that this a sub n is equal to what number? That's the number of 65, all right, is equal to, we know what a sub 1 is, namely negative 7, plus, and now what we do not know is this number n, all right? So we have here n minus 1 times, and we still know what our common difference is, namely 9. Okay, now let's just then do the arithmetic here. We have negative 7 plus, and now if we were to use our distributive property here, we have, anyone here? 9n minus 9, and then this gives us what? 9n minus, you may add these here, of what? 16, and then we have 9n then is equal to, and if we were to add 16 to both sides here, 65 plus 16 is 81, and we know that our number must turn out to be a positive integer because we are talking about a particular term, is that right? And so therefore n is equal to 9, and I think we will agree that this is our conclusion. Therefore, what can we say? But 65 is the what? Is the 9th term. All right. All right. Now I don't want to take the trouble to actually go through this, but negative 7, comma 2, comma 11, comma, and then you're adding 9 each time, the common difference, and when you get finally up to the 9th term, the number there should be 65. Okay? Let's look at another idea that is in this section, in which what we like to do is to look at the idea of an arithmetic mean or means. Now, let's approach this idea through an example, and then I think perhaps it will generate some more discussion. Here we have, find the arithmetic mean between 5 and 17. And so you say to yourself, well, there's nothing very difficult about that. I've been finding arithmetic means, which we have been giving another name, and that was called what, Tom? The average. We've been finding the average of two numbers for a long time. Let me call this number, well, let's call it capital M, in which, for the mean, in which we would say what? How then would we find the arithmetic average? How do we find the average, Doug?
1/2 times a plus b.
All right, 1/2 times a plus b, in which if a were one number and b were the other number, it may be written in terms of 1/2 of a plus b, which in this case is 1/2 of, and our numbers are what? 5 plus 17, and of course this then is 1/2 of 22, is that right? And so then the mean must be equal to 11. And you say, well, there's nothing very complicated about that. Let's approach it from a slightly different point of view, if I may. And what I'd like to do is to look at an arithmetic sequence, is what it is, of 5, comma, some element, comma, 17. Okay? And again, let's look at it from the point of view of our formula. We know that, well, let's just look at a sub n then is equal to a sub 1 plus n minus 1 times d again. Now, a sub n is the third element, is that right? Where n happens to be what number? N happens to be 3. So we'll have 17 then is equal to, and a sub 1 is 5 plus 3 minus 1 is 2, and the number that we do not know and that we would like to find is what? Is d, so times d. And now looking at this, we say, oh yes, 2d is equal to 17 minus 5, which is 12, and then d must be equal to 6, and sure enough, if we were to take the previous term, in this case the first element, which is 5 plus 6, that gives us the number 11. And you say to yourself, well, why go through all of this when indeed I can find the arithmetic mean by this formula right here? Well, the reason I did it this way is so that we can extend the notion of arithmetic mean to include more than one. We can talk about 3 arithmetic means or 5 arithmetic means between two given numbers. And we can't very well use a formula as we have here for the arithmetic mean, and the way in which we can arrive at it is through our general formula here in order to be able to find d. Okay? Let's look at an example of that. here we have find three arithmetic means between 5 and 17. Okay? Well, I notice I selected the same numbers. There's 5, comma, and then there's some number here, and then another number, and then a third number, and then finally we have 17. So here we have a sequence of how many elements? Of 5 elements. Let's write down our formula again. A sub n is equal to, and for the third, fourth time now, Kirby?
A sub 1
A sub 1
plus times
n minus 1 times
d.
d. Okay? And again, we're looking for this number d, the common difference. Is that right? What then is a sub n? What element is that? What number is that? 17 is equal to a sub 1, which is 5 plus, and now how many elements do we have here? How many terms are there? 1, 2, 3, 4, 5 terms that we're looking at, so n minus 1 must be 4 times d, okay? Therefore, 4d must be equal to 17 minus 5, which is 12. d then must be equal to 3. Well, if d is equal to 3, let's take our first element, the first term of 5, and add 3 to it, so the second term must be 8, the third term must be 11, and the fourth term must be 14. Let's check, and if we were to add our common difference of 3 to 14, sure enough we end up with the last term of 17. So therefore, let's actually write our conclusion, which it says what? The three arithmetic means, okay, means between, what are our numbers? Between 5 and 17 are, and what are they? They're 8, 11, and 14, then would be our conclusion. All right? Well, let's look at one more example. I think that that's all that we need to do for today. Here's perhaps a real-life situation. At the end of 1 year, the trade-in value of a certain car is $1,100 less than the original cost. Each year thereafter, the trade-in value decreases by $800 each year, all right? Now, if the original cost of the car is $5,800, what is the trade-in value at the end of 6 years? Well, I don't think it's a very difficult problem, but let's see how we can set it up. The original cost of the car was what? $5,800. And then at the end of the first year, it depreciated how much? $1,100. So then if we were to subtract $1,100 from this figure, we end up with what? We have $4,700. Now, this is at the end of the first year. So rather than thinking of this in terms of 6 years, let's think of it in terms of 5 years. And again, let's use our formula of a sub n then is equal to a sub 1 plus n minus 1 times d. All right, in which we are now looking for what? A sub 5, in which a sub 1 now happens to be what number? 4,700, all right, plus n minus 1, where n is what number? N is 5, so n minus 1 must be 4, times this common difference, which is what number? Well, I think because it's decreasing, I think we should think of it as negative 800. Okay. Now let's see where this leads us. We have 4,700, and here we have 4 times the negative 800 is negative 3,200, which is minus 3,200, and then we end up with a number which is what? 1,500. All right. So therefore, I think our conclusion is what? That the trade-in value, let's write it that way, the trade-in value after 6 years is what? Is $1,500. I'm not sure that one can get $1,500 for a 6-year-old car, however. Well, let me give you your homework assignment for next time. This will be assignment number 18.